This video tutorial is going to look at volume of those 5 shapes we looked at last day. And the big ideas today are being able to calculate the volume of a three-dimensional object given their dimension, and to be able to calculate one of the particular dimensions given the volume. So volume is the amount of space a three-dimensional object occupies. And as it's three-dimensional, it is a measure of cubic units. Cubic meters, cubic centimeters, cubic inches, whatever. And just as we thought of surface area in a particular way, a nice way to think about volume with respect to an orange, remember surface area of an orange is the peel. Well, the volume of an orange is the stuff you actually eat. So again, if you can visualize something, formulas and everything else become a lot simpler. Okay, let's look at prism. Well, if this is L and this is W and this is H as last day, the volume of a prism is simply a multiplication of those three things. Cylinder, well again, cylinders from last day, not too exciting. They have radius and height. And the volume of a cylinder is pi r squared h. So again, nothing new, that's all from last year, but they are really connected to the next two things we're going to look at. Again, pyramids have a height, and it's going to turn out, and L and W, I guess. So here's our H, here's our L, here's our W. And it's going to turn out that the volume formula for a pyramid is 1/3 L times W times H. And you'll often see it written like this. And B represents the area of the base, whatever that base means, whether it's a rectangle, a square, a triangle, pentagon, doesn't matter, area of the base. So I want you to be able to recognize both. And you should notice something interesting about the volume formula for a pyramid and the volume formula for a prism. We're going to take that up in class. Similarly, cones, not very interesting. They have height, and again it's perpendicular, and they have radius. And the volume formula of a cone is 1/3 pi r, 1/3 pi r squared h. And again, you should look up above and go, wow, that looks kind of like a cylinder. And again, we're going to take that up in class. And then finally, a sphere, the volume of a sphere is 4/3 pi r cubed. So again, all of these are on that blue piece of paper, that blue laminated sheet that you have in your notes. Again, we don't want to memorize. We want to be able to do the algebra and have a good understanding of what we're being asked. So let's go ahead and do 4 problems. It's always a good idea to draw a picture. So here's an example. Determine the volume of a cone with radius 7 and height 20 millimeters. So I'm going to draw my cone, and it's going to look like this. And the height is going to be 20 millimeters. And my radius is going to be 7 millimeters. And my volume is going to be quite straightforward. Again, get in the habit of writing out these formulas. It doesn't take you much time, and then what your brain does is it goes, oh, I know exactly where to put things, and they go in their place more easily. And again, we have to remember the units. And again, if I have radius squared, then, oops, we're talking about millimeters cubed. How about we get the right units, Mr. Nicholson? Um, if we go back to our units, then if our radius is 7 millimeters and we square that, then our units get squared. So we have millimeters squared, and then we have another measure of unit. So we have millimeters cubed. Okay, let's look at the next one. The volume of a sphere with diameter 16 millimeters. So here's my quick sketch of my sphere. And I put on the information I have. Well, the information I have is I know that the diameter is equal to 16 millimeters. And my volume formula is 4/3 pi r cubed. What I hope you recognize right away is in our volume formula, we need radius, but we're given diameter. Those are not the same, but there is a really nice relationship, right? Diameter is equal to twice the radius. So if my diameter is 16, then my radius is going to be 8. And we can go ahead and plug that in. And when we plug that all in our calculator and round it to the nearest 1 decimal place, we're going to end up with that many millimeters cubed. Okay, straightforward. Okay, let's look at a couple of examples where we want to find the missing dimension, the other thing we have to be able to do. A cone has volume 3 meters cubed, sorry, and a radius of 80 centimeters. So the first thing I want you to notice is the units do not match. So if we're going to do our calculations, we have to make sure our units match. Now I'm going to do the easy way, and I'm going to ask you to do the hard way. So the easier way is going to be to change centimeters to meters. And if I change centimeters to meters, so I'm talking about my height, so here's the height, here's the radius. Okay, if my radius is in meters, so it's going to be 0.8 meters, and I want to figure out the height. Well, again, our units are going to be meters because the volume of this thing is in cubic meters. In doing this, again, key thing is recognize the misalignment of units. Well, now what we can do is we can go ahead and the only thing, sorry, it says cone. The volume of cone is 1/3 pi r squared h. In looking at this, what do I know? I know volume, I know 1/3, I know pi is a number, and I know r. The only thing I don't know is h. And as long as I have an equation with one unknown, everything's good. So now we're going to plug everything in, and the only thing left over is going to be h. Probably the simplest way to solve this, I mean, you could do it algebraically. You could multiply both sides by 3 to get rid of the 1/3. You could divide both sides by pi and get rid of the pi, and then you could divide both sides by 0.8 all squared and get rid of that. But maybe the easiest way is to figure out what 1/3 times pi times 0.8 squared is, and as long as we take that to 4 decimal places, then we're going to be good. And in order to finish it off, what we're going to need to do is, again, to isolate h, to undo a multiplication with a division. And when we finally do this calculation, we get h is equal to 4.476. That's meters. So remember, our unit, we decided on meters. But we need to switch that to centimeters, and again the relationship is 100 centimeters per meter, so height is equal to 144.6 centimeters, but the question wants us to round it to the nearest centimeter, so here is our final answer. And what I'd like you guys to do is, instead of changing the radius from centimeters to meters, what I'd like you to do is to change cubic meters to cubic centimeters, and then figure out the height that way. And of course, it's going to work out to the same thing. I want to talk about that in class next day. Okay, let's do one last example. Write square pyramid as a volume of that and a height of that. Find the dimensions of the base. Now, given that it is a square pyramid, the L and W of the base are the same. So let's just draw our pyramid. And what we know is that the height of this pyramid is 15.1 meters. The volume of this pyramid is 554.9 cubic meters, so the units match. That's good. And now we have our formula, which is 1/3 base times height. Now this is a good time to do that base times height because it's a square base. The question is asking you to find the dimensions, so I'm going to label it because that's ultimately what I want to find. And given it's a square, we know that the L and the W are the same, so I'm just going to call it A. And now it's a matter of plugging in the numbers into the proper place. And again, we could do algebra, multiply both sides by 3 and divide by 15.1, but maybe the best way to go would be to multiply 1/3 times 15.1, and as long as you carry to your 4 decimal places, it'll work out nice. Then we're going to undo this multiplication right here, 5.0333 times b. We're going to undo a multiplication with a division. We're going to follow the golden rule to maintain equality. And what we're going to be left over is b is equal to 110.2450. Now, it might be really valuable to understand that that is the area, and that what that represents is the area of the base is 110 and a little bit square meters. But that's not what we're asking. But what we do know is that a squared is equal to the area of the base because it's a square. So a squared is equal to 110.2450, and we undo a square with square root and follow the golden rule, and we end up with A is equal to 10.5 meters. So the side length of the base of this particular rectangle is 10.5 meters.